Hello everyone, this is Guan-Ting and Manuel Giambi, and our topic is XLM-R for Cross-Lingual Reverse Dictionary. So what is reverse dictionary? The reverse dictionary is that you can input a description and output will be the target word that is corresponding to your description. And if the description and the target word is not in the same language, then we will call this cross-lingual reverse dictionary. Our motivation to research the cross-lingual reverse dictionary is that both of us are in the process of learning a new language, and we want a tool to help us learn faster to how to use that kind of new words. And the cross-lingual reverse dictionary is one such tool. And also we found that there is surprising amounts of valuable works on that kind of topic and a wealth of opportunities to explain on it. So here I want to mention two previous approaches on reverse dictionary. So the first is at 2013, they used WordNet to calculate the semantic similarity between the description and the target words. The second is at 2016, and they used the last output from the RNN model. They also learned a linear transformation to map the output to the pre-trained word embeddings. Their purpose is to find the closest word vector, so that will be selected for the target words. Here is the most three related words that use latest technique, and those techniques may be used for our project. Now I'm going to introduce a little bit about BERT's model. BERT's model used transformer-based architecture, and it achieved a lot of state-of-the-art at NLP tasks, such as question answering, summarization, and natural language inference. Inspired by the powerful BERT model, there's a research that used BERT for reverse dictionary. For monolingual tasks, they use a list of math tokens as the first segment, and the second segment is the description. So finally, the max language model will need to predict the target word ranking. As for underlying cross-lingual tasks, they add the extra language embedding. When training, the language 1 and language 2 will be the same value. This is because we don't have paired cross-lingual data. But in the evaluation stage, then we can change the language 1 token to predict the target word that in another language. The result is quite surprising. As you can see in the table, by using multilingual BERT model, we don't need any paired data, but we can still reach not bad performance. And in the right-sided table shows that if we input a Spanish definition into monolingual reverse dictionary and translate the target Spanish word into English, the result will be wrong. But the unaligned cross-lingual reverse dictionary can output the correct answer. It may be because that it considers the context, not a single word translation.
State-of-the-art on cross-lingual reverse dictionary is currently achieved by multilingual BERT or MBERT, which is just a BERT model which has been pre-trained on multilingual datasets. We can say that MBERT gains an understanding of natural language which goes beyond any specific language, and we found out that it works well on low-frequency languages, which means languages for which we have only few examples. An evolution on MBERT is XLM-R, a new BERT-based model developed by Facebook, which has been trained on several orders of magnitude more data, and it features 100 languages compared to the 88 MBERT has. For English, it uses around 56 terabytes of data. Our goal is to use XLM-R to tackle the cross-lingual reverse dictionary problem, and we would like to show that performance can be improved, and hopefully we can achieve a new state of the art. we would like to look at two special cases. One is the underlying cross-lingual reverse dictionary, which means we want to fine-tune our model on an English dataset and evaluate it on a completely new language. Also, we would like to try and introduce structured knowledge into the problem. We would like to take this structured knowledge from WordNet. We want to use data that has been released by the researchers, and we want to start from pre-trained XLM-R models. And then for fine-tuning, we want to use datasets that have been used to achieve the current state of the art for the sake of comparison. The main piece of software we will have to write is a PyTorch module that takes a pre-trained XLM-R model and fine-tunes it for our task. Since we're using a pre-trained model, the computer resources won't be as high. We plan to split the work symmetrically between the two of us and work together in all phases of the project, from prototyping to implementation and testing, which we will do on our own GPUs, and then finally the write-up. By midterm, we plan to have fully understood the existing models and have read all the research on the topic. We would also like to reproduce the latest results for the monolingual case, and ideally also for the cross-lingual case, and look at new approaches to improve upon what has been done already.